Okay, so this last question, question 13, is some three-dimensional trigonometry, and we need to calculate the angle DFH. So DFH, what does it look like? So let's draw some line from D to F, and then F to H. The angle that we're after is this angle here. Let's call that angle X. That's the angle that we're trying to find here. Look at this line here that I've just drawn. That's sitting on the base of this rectangle, okay? And therefore, we know that the base is at right angles to this vertical. So that's a right angle there. So we end up having a right angled triangle in that. And we're trying to find an angle, so we need a side now. So it seems sensible to try and calculate the length of this side, FH. So let's do that first of all. So remember that this length here is 5, because this length here is 5, which means this length here is 5, which means this length here is 5. And we end up with this triangle here. This is another right-angled triangle with half of that base there. It looks like this. This is the triangle that we're dealing with here. And this is F and H, and this is 5, and this is 12. So we can just use Pythagoras to find FH, and if we know that in actual fact that this is a Pythagorean triple, 5, 12, 13, we should be able to say that this is 13. So FH is equal to 13 because this is a 5, 12, 13 triangle. If not, we would have to say that FH squared from Pythagoras is 5 squared plus 12 squared, so FH squared is 25 plus 144, so FH squared is equal to 169. So FH is the square root of that, ignoring the negative root. The square root of 169, so therefore FH is 13. Okay, but you can certainly save some time now with Pythagorean triples there. So that tells me that this length here now is 13, this FH. Right, so let's go back to our triangle that we're actually dealing with here. And the triangle that we're dealing with is this triangle. That's H, that's D, and this is F, and this is my angle X. This length here is 5. This one is FH. We just calculated that's 13. So how do I calculate X? Well, it's a right angled triangle. I'm trying to find an angle, so it's SOHCAHTOA. Let's label our triangle now. So angle opposite the right angle is the hypotenuse. I don't need that one. I'm not even going to involve that one. But this one is the opposite, so I'm going to involve the opposite, and this one here is the adjacent, the one that's touching the angle. So I've got the adjacent and the opposite. So adjacent and opposites. So we've got two ticks above the TOA. So that tells us that the tan is being used. So the tan of X is the opposite, O, which is 5, over the adjacent, and the adjacent is 13. And that tells me that X is the inverse tan of 5/13. And we'll do that on the calculator. Inverse tangent of 5/13. And we get 21.04. 21.04 degrees. And that's our answer.